So now let us look at one possible solution to basically mapping virtual memory to physical addresses. We actually talked about this a bit in the beginning of the course using base and bounds registers, where you basically keep two values in registers for the process, a base and a bound value. When the CPU issues loads and stores, it will add base and check if that value is less than bound. So you basically tell the operating system that this process, or the operating system basically allocates to this process basically a base, which is like, okay, this is where the process starts, and a bound where, okay, this is where the process memory ends. Okay, and whenever you do any memory allocation, or you try to do loads and stores, basically trying to read memory or allocate memory, you will add the base. Basically, when you're doing stores, you'll add the base and grow, okay, and check if you're growing beyond your bound. So your physical address will be a virtual address plus a base, okay, because you will always start with 0x0 for your virtual memory for a program. That means that your base, adding the base to 0 to whatever you have, will basically get you to where you want to start in the program. Okay, and this can be done very fast in a special purpose hardware that's called a memory management unit. It's actually part of almost all computers. It's part of your memory system, like your hardware memory system. It basically does this addition for you, so the CPU does not even need to worry about doing these additions and comparisons. Okay, it's a very simple logic circuit basically. Okay, so what happens if a process attempts to read memory beyond the bound? Yes, the MMU will issue a software exception or a trap to the operating system, telling the operating system that this is trying to access memory beyond its bound. Now, how you deal with that is a different question, because if you're trying to read something beyond your memory, then of course you can basically kill that process. But if you're trying to write, well, you might just be running out of the allocated memory and you might need more memory. So this brings us to the disadvantages of this approach. First of all, you get external fragmentation. Basically, you have a process C. Okay, maybe the process is happy with the memory allocation, a process B that is happy with this memory allocation, and the process A that is happy with this memory allocation. And then a new process comes that actually wants or requires the sum of all of the free memory that you have in your memory. Meaning you want basically a whole chunk of memory that is basically all of the free combined together. And this can happen, I mean, because you have processes coming and going. Maybe when you did the allocation, you actually did the allocation such that there was a process D up there, a process E, a process F, and a process G. But these processes just died or finished processing, so you got this fragmentation in memory. Till now, we have not discussed anything that will help us solve this issue. You might also have internal fragmentation, because you basically, if you have a base and bound, then what you would typically do is that you will have you'll have the bound. You will have basically constant memory allocation for any process. So any process that comes gets allocated 16 KBs. Okay, maybe the process needs just 1 KB, and you have just wasted 15 KBs on nothing. So you have an allocated part of the memory that is not used. Okay, so how can you basically make sure that you're not wasting your memory, basically declining some other processes to run because, well, I'm out of memory, while what you're actually having is a problem where you have internal fragmentation. You're not really using memory that you have allocated. This is another disadvantage to this approach. So let me ask you a question. What would happen if the process could modify its base and bounds values? Is that something that we want the process to do? So yes, I hope that you basically realize that it's all of the above. Okay, let us ask another question. If the process is not running, can the operating system change the base and bounds and move the address space in physical memory? Yes or no? Actually, yes. And this is basically what we are going to study next.